an ultra-hot exoplanet not much larger than Earth may experience trillions of lightning flashes in just 1 hour. Astronomers say the entire surface of this exoplanet, called Kepler-10b, could be made up of constantly erupting volcanoes, causing its atmosphere to be extremely electric. Along with Kepler-10b, researchers have predicted the lightning patterns of numerous exoplanets based on observations from storms throughout the solar system, including those on Earth, Venus, Jupiter, and Saturn. In a study published recently to the journal RZIV, researchers led by Gabriela Hodozin of the University of St Andrews, UK, investigated the occurrence of lightning on several exoplanets and brown dwarfs. Eventually, astronomers may be able to detect radiation from these lightning bursts when the planets travel across their stars, according to New Scientist. These objects were divided among 6 categories: Earth-like planets, water world, rocky planets with no liquid surface, Venus-like planets, giant gas planets, and brown dwarfs. According to the team, planets with high volcanic activity are likely to have the largest lightning flash densities. Such objects include the rocky planets Kepler-10b, described as a hot, tidally locked rocky super-Earth, and 55 Cancri. These planets supposedly do not have permanent liquid oceans on their surface. However, they still may host a chemically active atmosphere that forms clouds and produces lightning, the authors wrote. Lightning production on these planets may also be caused by volcanic activity or electrostatic discharges caused by dust collision. The team considered multiple scenarios for the lightning activity at these exoplanets, using data from the eruptions of Mount Redoubt, Alaska in 2009 and Eyjafjallajökull, Iceland, in 2010. This allowed for the possibility of both high and lower flash densities. For example, if we assume that the surface of these planets is covered by almost constantly erupting volcanoes, the flash densities could be very high, like during the Phase 1 of the Mount Redoubt eruption, the authors explained. However, the surface is still covered by volcanoes, but they don't erupt as frequently, or the frequency of explosive eruptions is less, then a smaller flash density can be used, like during the eruptions of Eyjafjallajökull. If Kepler-10b is covered mostly in volcanoes, the researchers determined it should experience between 100 million and 2 trillion flashes in the time it takes to travel across its star. This period, just 2 hours for Kepler-10b, is when astronomers are best able to study exoplanets. The researchers also looked at less explosive exoplanets, including the gas giant HD 189,733b. This blue planet is roughly the size of Jupiter, and is thought to experience about 100,000 lightning flashes per hour. This was determined based on data from storms on Jupiter and Saturn. Understanding lightning activity on exoplanets could help to provide clues on the possibility of life on alien worlds, according to New Scientist. Lightning can help to form the molecules necessary for the evolution of life. As the research continues, the astronomers say it could one day be possible to detect the radiation from these lightning bursts, but more calculations will be needed first to determine if the flashes are bright enough to be seen by Earth-based telescopes.